So a story comes out recently talking about Earth's rotating in reverse direction. I don't know if you saw that or not. I'm sure you have. So scientists have confirmed that the Earth's inner core, Rob, if you want to pull up the story, has started to rotate in reverse direction. According to a research study published in Nature, scientific community has been struggling to confirm the phenomenon for years, but the new evidence supports a 2023 hypothesis about the inner core's rotation rate. Now, some are saying, man, you got to be careful with this because this is the end of time. This is this is that. What does it really mean when the Earth's core is now starting to rotate in reverse?
I think with this story, it got a little bit misrepresented.
Okay.
So first off, full disclosure, I'm an astronomer. I do not study the insides of the Earth. I'm not a geologist. I took, when I was at college, I took geology. So that's one of the subjects I studied. But this is a story which I think, from the outside, seems to be misrepresented. So my understanding of what's actually happened is that there are inner layers of the Earth which are rotating. And imagine that there's two layers and they're rotating in the same direction, but one's going faster than the other one. And then what's happened is, even though they're both going in the same direction, the inner one or the outer one is now going faster than the other one. So they're both still rotating in the same sense. It's just that the relative motion as to which one's going faster has changed. That's what's flipped. So it's a reversal in the differential speed between them, but not the absolute speed. So they actually are still going in the same direction. But of course, that doesn't make a very snappy headline. So I think a lot of the confusion was people misrepresenting this story a little bit and seeing it as though it really was like the inside was completely flipped over.
So this inner core intrigued researchers since its discovery of Danish seismologist Inge Lehmann in 1936, and how it moves. Its rotation, speed, and direction has been at the center of a decades-long debate. A growing body of evidence suggests the core spin has changed dramatically in recent years, but scientists have remained divided over what exactly is happening and what it means. Part of the trouble is that Earth's deep interior is impossible to observe or sample directly. So what is the risk? Based on just what you know about, you're an astrophysicist, not a geologist, but what is the risk if it does go the other way? What do we know if it does do it? Like, what's the big deal if it does?
I think the risk for us is probably the magnetic field is a big obvious risk. So, we are bombarded by cosmic rays, high energy radiation from space, and that's striking the surface. If you're underneath the ocean, you're dwelling in the ocean, not deep down, you're probably fine. You're not going to be affected by this cosmic radiation. But if you're on the surface and we suddenly lose that magnetic field, that's what gives us like Aurora Borealis, the Northern Lights. Without that, we're going to be exposed to far higher levels of radiation. And so this is thought to be potentially a crucial criteria for looking for planets which could have life on them. We want them to have strong magnetic fields. If the Earth's magnetic field, and we actually do think over millions and millions of years, it does flip. So the North and the South Pole do flip periodically. We see that in the geological record. I remember learning that at college when I was studying geology. You see these magnetic lines on the sea floor which kind of strip over. So the magnetism of the surface, as you look at different layers of the ocean bed, have actually flipped in their magnetic behavior. So we know the Earth's magnetic field does flip. The question is, how fast does that flip happen? Does it happen like overnight? And so you go to bed at night and you got a strong magnetic field, and while you're asleep, suddenly the field switches off, but it goes back to normal just the other direction, fine. Or does it stay off for tens, thousands of years, which would be very bad? That could actually severely impact life on the surface, including us. We just don't know, but it is likely that it will flip again in the future.
But it's not a crisis if it does.
It depends. We don't really know. We've never sat through one. So, we've got this geological record, but that's so granular. It's not giving you that fine detail.
How did they even find out, by the way? How do they know that's happening?
So they know this from looking at when you look at the ocean bed, there's these layers of material, sediment, which fall onto the bottom of the bed. And that's basically like a time capsule. So if you dig deep down, you're seeing a layer which corresponds to hundreds of millions of years ago. And you can measure the magnetism of that layer, and you see that it is flipped compared to the next layer and the next layer. It's going opposite and opposite and opposite. So from that flipping, you can tell basically from the thickness of these sediment layers, roughly how long the Earth's magnetic field is flipping. So I don't remember the exact number, but sort of millions of years or so, you see this flipping happen. So it is inevitable, I think, that the magnetic field will flip. And we certainly think, when we talk about astrobiology and the search for life in the universe, that having magnetic field should be a really important criteria for life. So I certainly hope, and I think you should hope as well, it doesn't happen in our lifetime, because it could be a bad day.
Yeah, that makes sense. So obviously, we will be praying for that not to happen.
Yeah.
Because based on it, it could be a confusing time.
Me too.
But for a guy like you, astrophysicist, you know, somebody who goes to school and you're studying this topic, right? One, what makes you study a topic like this? Like, since you were a kid, was this something where you were fascinated with it?
Yeah.
And then two, now that you have, and you're in it, and you've read all these papers, you've written papers, you've been around all this, the community, what's keeping an astrophysicist up at night?
Well, I was always fascinated by the universe, I have to say. So ever since I was like 5, 6 years old, about the same age as my son, we were just talking about as we came on, you know, he's got the same kind of bug as me. Like he just has all these questions about the universe and space and everything really, but especially astronomy. And so I was like that. And I remember getting this book that my parents bought me, and it was an annual of the planets, and it had, you know, a page all about Jupiter and all of its moons, and then Saturn with its amazing rings, and it had even more moons, and the size and mass of these things was just mind-blowing. I just couldn't believe what was out there and how large and vast the universe was. So I really caught the bug. I got into science fiction a lot when I was a teenager. I was watching all the Star Wars, Star Trek stuff, loved all that kind of stuff. And then when I was at high school, I remember my high school teacher said to me, you know what, you should, you know, here's some physics books. I would, you know, maybe look into particle physics and quantum physics and stuff like this. So I started to read books on that. I got hooked into that world. I kind of left astronomy, did my degree in physics. And then towards the end of my degree in physics, I came back to astronomy because there's so much left to discover. I think in physics, we often get the feeling, at least I had as a student, that to make progress at this point requires billions and billions of dollars. It requires huge teams, hundreds, thousands of people. And you will be, you know, accredited down there as like the 5,000th person who contributed to this. And some people get a kick from that, but I'm more, you know, maybe entrepreneurial, and I like doing things by myself and driving something forward. In astronomy, you're never going to run out of stuff to discover. There's 100 billion stars just in our own Milky Way. There's only 10,000 astronomers on planet Earth. So each of us has millions of possible star systems that we personally could just have as our own star systems.
There's only 10,000 of you in the world right now.
Professional astronomers.
Wow.
Yeah, professional.
Interesting.
Yeah.
And is there a community where you guys all get together? Like, is there the annual convention when everybody gets together and meets each other, or no?
Yeah, there's a few different organizations like the International Astronomical Union, IAU. That's the organization which famously demoted Pluto.